All right, here we go. A couple little short demos here. One of the experiment solutions in Tinkercad for the filter circuit. In this case, here it is, the full wave rectifier. Notice that Tinkercad doesn't do such an excellent job to provide you the full signal of a full wave rectifier, but it does show you that there's some rectification happening. Anyways, that's a rectified signal, and it's an unfiltered signal, right? This is the output, this is the input. I am going to place a small cap. Actually, what I have here is let's do 100 microfarad cap. So this is 100 microfarad cap. I'm going to place that across the resistor, and you're going to see the change, which is significant. Yeah, that will be my ripple voltage. Pretty nice. It accounts for, so full scale is 20 volts. 1, 2, 3, 4, 5. That's about 2 volts per division. So roughly the ripple voltage is like 2 volts in here, right? That's the ripple voltage of the rectified signal. Okay. You can also add a DC device, measure the DC voltage in here. All right. Okay, so we can just do that. Use this voltmeter to measure voltage across the load, just to give us an idea how it looks like. All right, pretty nice. That's about 7.6 DC, right? And that's the ripple voltage. Recall the ripple voltage is current divided by FC, so you can do the calculation. But that's the ripple voltage with 100 ohms microfarad capacitor. I'm going to change that cap to a larger cap. I'm going to make this 300, and you're going to see the effect of that. An improvement both on the DC output and an improvement on the reduction of the ripple voltage, right? Because the idea is we want to have this DC rectified signal as straight as possible. So anyhow, that is that. Here's all right. Here's the second one on Tinkercad, the full wave rectifier. Actually, the bridge rectifier here is the one with 4 diodes. If I run it, I actually get the rectified signal. In reality, it's funny how this works. If I remove this ground here, it will show me the completely fully rectified signal. Okay, and that's that. So when I filter these, it requires that additional ground for the cap. So I'm going to stop here, and I'm going to place the cap across the load, and notice that nothing happens. But if I do a ground at this point, then I have a filter signal, right? And that's pretty good. That's not completely filtered, but again, you can make improvements on that by changing the value of the cap. Let's make it 200. And notice how that improves greatly, right? At 200, we got a lower ripple voltage. And even if I do 300, I think I get the best buck for my design here. So there we go. That's even a nicer rectified signal. So anyways, you got a couple of flavors. You got the full wave and the bridge rectifier. Note that the bridge rectifier needs an additional ground here in order to work properly when we do this, okay? I hope this helps. You can do the same with multisim, okay? And I expect that you'll use either Tinkercad or multisim for this pre-lab. Thank you.